was really fast. Okay. All right. I apologize for waffling. I don't do that very often, but yeah. Okay. So today we're talking about multiplicity and what multiplicity is, and we're going to use multiplicity to help us graph polynomials because everything is about the graphing. The multiplicity of a zero is the degree that it happens, the number of times that it gets repeated. And so we're going to see what happens here. We want to find the zeros of the function below and their multiplicities, and I'll tell you more about that multiplicity in a second. Zeros are where our function is equal to 0. And when I look at these three terms here, is there something we can do? G, C, F, greatest common factor. Yeah, what do they have in common? All three terms have an x. Woo! We need to stick. All right, so we have x squared plus 10x plus 25. And then we can double bubble this little trinomial there. So we have x, and then we're going to double bubble. How does x squared plus 10x plus 25 double bubble? 5 and 5, yep. X times x gives me the x squared, and positive 5 and positive 5. And so this has some repeated factors. And what we can do is we can condense this. Since it's being repeated 2 times, I can write it as x plus 5 quantity squared. Well, anytime you have a repeated factor, that is what is called multiplicity. It's multiplying itself, okay? So that's called multiplicity. And so we have our zeros here. The zeros we have are setting each bubble equal to 0, so we get x equals 0. And over here we get x equals -5. And what we say is it's -5 multiplicity 2. Multiplicity 2 because it's happening 2 times. And what that does is it does something very interesting to the graph, which I'll talk about in just a minute. And so our zeros are 0 and -5 with a multiplicity of 2. 0, how many times is 0 happening? Just the once, okay? It didn't repeat itself, so that's fine. All right, on this graph, again, we want to find the zeros. So once again, what can I do to factor this? I can take out a GCF again, and I'm going to take out, because there's a leading negative, I'm going to take out negative x squared. If I take out negative x squared, what's left behind? So minus 6x plus 9. Very good. All right, and then that trinomial, we can double bubble. So I have negative x squared, and I'm going to double bubble. Yeah, x times x is x squared, and then -3 and -3 is how that gets the 9 when we multiply and the -6 when we combine them. And so again, you see here, I can clean this up, condense it, because x minus 3 has been repeated 2 times. So this is its most condensed form here, and my zeros then are x equals 0, and you'll notice it got repeated 2 times. So that's called multiplicity 2. And then we also, what's the 0 from this bubble? 3. And again, because it's repeated 2 times, that's a multiplicity of 2 as well. All right, so graphically, multiplicity does some very interesting things. And so I want to show you, I'm going to go ahead and type in, I have a couple functions that you want to write down probably as well, but you don't have to actually. Oh, wait. Well, I'll show you in just a minute. So go ahead and write this down. We want to identify the zeros. What does LT stand for? Leading term. And sketch. And what I have here, this is real interesting. This is called factored form. Everything's been factored. All right. And if I want to find the zeros, well, it's pretty easy. I just set each bubble equal to 0. If x is equal to 0, well, x equals 0. So there's a 0 right there. And then what's another 0 right here? We get x equals, if I set x plus 3 equal to 0, what do we get? Oh, you're writing it down. -3, thank you. But this one, x plus 3, has a power of 3. So what's its multiplicity? Yeah, that has a multiplicity of 3. I'm sorry, you guys are writing that down. I forgot. And then our last bubble here is x equals 2, and it has a multiplicity of 2. Are you done copying down this first one? Yeah? Okay. So I want to show you, I'm going to type this in so you guys can keep writing here, maybe the second one, while I type it in for you. And we're going to see what this looks like. So I'm putting it in. There we go. And before I do anything, I'm just going to go ahead and sort of sketch. I know I have a 0 at 0. I know I have something happening at -3. And I know I have something happening at +2. So those are my zeros. And I want to, I don't know exactly what it would do. The other thing I need to think about is the leading term. So what is our leading term here? Well, how do we figure that out? The leading term is the highest power of x. Imagine if we were to multiply all this together. What would the degree of x be? Crazy, huh? Here, if you were to expand this, you'd get x to the power of 2, wouldn't you? Yeah. What would you get for this one? It would be 6. Yeah, it would be 6. Here we'd get x to the 3rd power. So what I've really got here is we have x to the 1st. Here we're going to get x to the 3rd, and here we're going to get x to the 2nd. And if you just add the exponents. The leading term is actually 1/24 x to the 6th power. And so what do we know when it's x to the 6th power? What should the arrows do? Yeah, they both be arms up, right? Okay, let's see what this looks like, because it's quite interesting. Ooh, interesting. What happened at the 2?
It went all the way up.
Well, it appears to hit the graph, hit the axis, and I call this a bounce. Can you imagine a ball is coming down and what's it doing? Bouncing off the ground, okay? And that happens because of the multiplicity of 2, okay? And then 0 just had the multiplicity of 1. So at 0, you can see it just went straight through. So it just passes through at 0. And then what's it doing at -3?
Kind of like hitting the top of the hill and then rolling down.
Yeah, it's sort of hitting the hill and rolling down. Yeah. So I call that it's cubic in nature. So it looks kind of like our little cubic graph as it goes through, and that's because it has a multiple of 3. I call that a kick. I imagine if it were just to go straight through and then I kicked my foot and I hit it and it made a dent. Okay, I call it a kick, and that's because the multiplicity of 3. And so what we have here is our leading term had a power of 6. So we start up high. And what happens is I have approached -3 first. Because it has a multiplicity of 3, what we're going to do is we approach it and we go a little bit on the left, and it sort of kicks through. So we get a little jog to the right at that 0. And then the next thing we're going to approach is the 0. And at 0, it doesn't have any multiplicity. It's just 1, power of 1. It happens one time. we just sort of pass straight through. And what that really means is it's going through in a linear kind of fashion, like a straight line. And then at the next zero, which is at a 2, we have a multiplicity of 2, and I call that the bounce, where we're going to hit the axis and bounce off of it, all right? So we sort of go up and turn around, and I bounce right off the axis and then end back up like that, which is quite interesting. And so let's look at B, and you can see again, so when we have their multiplicities, they're going to either pass straight through, they're either going to bounce if it's a multiplicity of 2, or if it's a multiplicity of 3, it's going to do a little jog to the right, which I call a little kick, all right? It just does a little jog to the right, which is kind of interesting. So let's look at this one. We have h of x equals negative 1/16 x cubed times the quantity x plus 3 squared times x minus 2. So we want to find the zeros. So we get right here just x equals 0. And what's its multiplicity? How many times do we get, is that being repeated? 3 times. All right, so that's a multiplicity 3. And it's a multiplicity 3 on my graph. That's going to give me a little kick to it. Here, what's our 0? Negative 3. X equals negative 3. And what's its multiplicity? 2. All right, so this is multiplicity 2. So that's got a little bounce to it. Bounce with me, bounce with me. All right. And then the last one we get x equals positive 2. And what's the multiplicity on this? 1, yeah. So this one is just a pass. It's just multiplicity 1, okay? All right, so graphically here, I'm going to just write in my zeros. I have here a 0, 0, at negative 3, and at positive 2. And I can just to keep myself organized here, I know that at 0, I got to do a little kick, a little jog to the right. At negative 3, I got to bounce off. And then at 2, we're going to pass right through. All right, but before I do anything, I need my leading term. So for all the money in the world, what's the leading term here?
Negative 1/16 x to the 6th power.
X to the 6th power, good. We got our coefficient in front here, negative 1/16. X cubed, x squared, x to the 1st. 3, 2, 1, add them up, we get x to the 6th. So negative 1/16 x to the 6th. All right, x to the 6th, what do the arrows do? They're both up, but it's negative in front. So they are both down, right? So it's something like this. And so we're starting low on the left here because we have the negative in front. And what I'm going to do here is I'm going to hit this negative 3 first, and I need to bounce off the axis because of the multiplicity 2. So I come up, and I bounce right off the axis. And then I got to turn around and pass through the 0, and I'm going to pass through with a little kick. So I turn around, and it does this little jog to the right, and then goes up. So it has this little jog to the right, little kick to the right. And then I got to turn back around and pass straight through the 2. So I'm going to turn around and pass straight through the 2, because it just has a multiplicity of 1. So interesting. I find these so interesting. And of course you can check with your calculator, but you'll do enough where you'll get pretty good at it. It's quite fun. But I'm a math teacher, so what do I know? X minus 2. All right, and so you can see, there it is. Pretty good, right? Like, this is what I think is super cool. Just knowing the factored form of something, we get a pretty decent picture of what it's supposed to look like. So let's just do one more here, and then I think you'll have it. So here's our function again in factored form. What are the zeros? And their multiplicities. What's our first 0 here? x equals 1, and it has a multiplicity of 2. And a multiplicity 2 is a little bounce. All right, this one, what's the 0 here in 2x minus 3? 3 over 2, very good. Yeah, add 3, divide by 2. And what's its multiplicity? 2. Again, it's got a power of 2. So again, that's another bounce off of the axis. And then our last one here is x equals negative 4. And what's its multiplicity? 1. So that is just a pass straight through. And I just need the leading term. This is one that's a little tricky. What's your guess for the leading term?
X to the 6.
It is not x to the 6th.
2x. 6.
You're getting closer. This one's a little tricky. Here you're going to get x squared.
Yeah.
This is 2x, and the whole thing is being squared. What does that give you?
4x squared.
Ah, 4x squared, yeah. And then this one is just an x. 4x to the 5th, yes, it's 4x to the 5th. Very tricky on that one. 4x to the 5th. Okay, so my little sketch here, let me think about this. My zeros are at 1. 3 halves is 1.5, so I'm just going to do a 1.5 there. And then negative 4 is over here. And again, I'm just plotting and labeling. I don't care how accurate we are. That's not the point of this. 4x to the 5th. What do the arrows do on 4x to the 5th? Okay, so is it starting low and ending up high, or yeah, okay, low to high. Starting low and ending up high, so that's where the arrow should go. So we're going to start low on the left, and at negative 4, it tells me by multiplicity 1, I'm going to pass straight through. So I'm going to go straight through negative 4. The next thing I'm going to approach is the 1. And at the 1, it had multiplicity 2, so what do I have to do at the 1? Bounce off of it. So I got to turn around and come back down and bounce off the 1. Bounce off the axis. And now I'm going to approach the 3 halves, and again, I got to bounce off the 3 halves. So I got to turn around and bounce off the 3 halves, which is quite interesting. And again, you can always double check if you want to. X minus 1 quantity squared. We have 2x minus 3 quantity squared, and then x plus 4. This one's not going to be quite as good as mine that I did before, just because there it is. So you can't quite see it as well. Let me change my Y so you can just see what's happening closer to the graph here. Oh, you can't even see that. Let me get even closer. So these are my problems that I've used for years, and that 1 over 16 and 1 over 24 makes the graph shrink a whole lot. Oh my gosh, I totally messed that up. Negative 2 to positive 2 is what that was supposed to be. Oh no. Negative 1 to positive 1. Okay. So there it is sitting at negative 4, passing straight through. And then it should come down. Oops, and there it is. There you see it. See that? There's a little bounce there. Bounce off the 1 and bounce off the 1.5, which is kind of interesting. Okay. So very interesting. And that's it, ladies and gentlemen. Do you kind of get that?
Yeah.
Yeah. All right. Everything is factored. And again,